This is lesson 3.3 special cases equations. The goal is I can identify when an equation has no solution, one solution, or infinitely many solutions. And the second one is I can solve an absolute value equation. So solutions to equations. In most cases, the equations we've been solving have only had one solution. And we find that by isolating the variable. We worked on that quite a bit this week in class. And so just to demonstrate, we're going to get the x by itself on the left side. Well, there are two values attached to the x. We've got a -7 and a positive 30. And the positive 30 is connected with addition and subtraction. We always move those terms first away from that side. So we're going to subtract, do the opposite, right? So those cancel, and I'm going to be left with 28 on the right side and a -7x on the left. And I would divide to break that bond. It's -7 times x. So to break that, I divide by -7, and I get a value of -4 for x. Okay? So just one solution, one answer only. Some cases, though, an equation may have an infinite number of solutions. So when we try to isolate the variable disappears. So in these cases, the remaining equation, if the remaining equation is true, then you get infinitely many solutions. So once your variable disappears, the remaining equation must be true for there to be infinite solutions. Let's do this one here. First of all, you notice, I hope, that there are parentheses with a number outside. That's distribution. So I have to distribute on the left and distribute on the right. That's going to give me 14x plus 10 on the left. I got to watch my signs over here on the right. -2 times -7 is a positive, and 2 times 7 is 14, and there's an x, and then negative times negative is a positive. 2 times 5, 10. And you notice here, if I get my x terms on the same side of the equation by subtracting 14x, they cancel on both sides, and that leaves me with 10 equals 10. Well, that is a true statement. Okay, this remaining equation here, 10 equals 10, is true because 10 equals 10. So you would say this has infinitely many solutions. Okay, so when it has an infinite number, we can often write IMS as infinitely many solutions to kind of abbreviate that because it's a lot to write out. But in some cases, you're solving that equation and the variables drop out, but the remaining equation is false. Well, let's see what that looks like. So we're going to distribute on the left, distribute on the right. I get a -35, and there's an x. And I get a -15. I get a 7 times -5, that's negative again, 35x, and I get 7 times -2 is -14. So I'm going to get my x's together by adding 35x to both sides of the equation. And again, the variables cancel, and I get -15 equals -14. But that statement is not true. -15 does not equal -14, so we would say that there are no solutions. Okay. All right, so you've got some cases where you solve an equation, x stays in the equation, and eventually you get one solution. Sometimes your variables drop out and you get a true statement, and sometimes the variables drop out and you get a false statement. When it's true, you're going to have infinitely many solutions, and when it's false, you're going to have no solution. So really, for infinitely many solutions, what that means is it doesn't matter what number you plug in for x, these two sides are always going to be equal. So you could pick any number at all right? So let's do some examples here. I'm going to distribute this negative. See this negative sign here? That's a sign switcher, so it's going to switch my 7x to -7x, and it's going to make it a -8. And I've got a -4x and a -8. So I'm going to get my x's together. I'll move the smaller one. I'm going to move the -7x to the other side of the equation by adding 7x. So here they cancel, and I have a -8 on the left side still. Then I have a positive 7x and a negative 4x, and the net there is a positive 3x minus 8. Well, the 8's need to be together to get the x alone, so I'm going to add 8 to this side and 8 to this side. And I know this confuses some people. They think, oh, it's just 3x because both sides canceled out. But the variable hasn't canceled. What's negative 8 plus 8? Well, that is 0. 0 is a number. So don't leave that empty over here on the left side. Put a 0 there because that's what you get when you add those two together. The variable is still in the equation, so this is not a no solution or an infinitely many. It's just one solution. You divide by 3, and x is 0. Okay? You try this next one. Shut the video off, give it a try, and start back up when you're done. So I've got double distribution, one on both sides. So I'm going to do positive 12, negative times negative is positive 12, x, and then a positive 14. Then I have a negative 10, x, and a positive 14. So now my x's need to be together. So I'm going to add this negative 10x, add positive 10x to both sides. Here they cancel. And here I get 22x. I still have my plus 14 and my 14 over there. Now my 14s need to be together, so I'm going to subtract 14 from both sides. And we saw this in class the other day where one of the equations had a 0 on one side of the equation like that, and it just really threw you guys off. So I thought we'd probably need to put that one in here a couple of times to see it and realize the variable x did not drop out. X's are still in the equation. The constant dropped out. It just left us with a constant of 0. When you divide by 22, 0 divided by 22 is just 0. Okay? So let's check this one out. I got a negative 2x plus 4 and a negative 2x plus 5. I bet some of you could look at that equation and realize what's going to happen. But let's go ahead and solve it just to see anyway. I can't combine anything on the left or anything on the right, but I've got terms on the left that are the same as some terms on the right. So I need to move my 2x here over here with my other negative 2x like this. And that's 0 plus 4 equals 5. Well, what happened? Now this time my variable did drop out and I got 4 equals 5. That is not a true statement, so this is no solution. You guys try the next one. Stop the video, start it back up when you're done. So distributing, I get negative 6x minus 9 equals negative 6x minus 9. Well, I can already see what's going to happen on this. I hope you can too. I'm going to get my 6x's together by adding 6x to both sides. And they both dropped out, and I got negative 9 equals negative 9. And that is a true statement. So my answer is infinitely many solutions, or IMS. Okay? So in this one over here, the variables dropped, but 4 did not equal 5. That was no solution on this side. The variables dropped out, and I was left with negative 9 equals negative 9, which is true. All right, example 3. So again, I love this distribution. Lots of practice for you guys on this. Okay, we get 28x plus 28. And I got a positive 7, negative 7 times negative 4 is positive 28x, and then positive 28. Well, hopefully you can see this is just the same equation on both sides. So if it's the same on both sides, it's going to be infinitely many solutions. So let's do the math and see how it works out anyway. I'm going to subtract 28x to get my x terms together. That cancels, and I get 28 equals 28. And that is true, infinitely many solutions. Okay? You try the next one there. All right, more distribution. Positive 48x. Positive, no. Negative 6 times 7, negative 42. positive 35 and positive 42. Well, this one, the x's don't look the same at all. I don't think they're going to drop out. Let's get the x's together by subtracting 35x. And it looks like I get 13x minus 42 equals 42. Well, my variable didn't drop, so I know I'm going to get one answer. So I'm going to add 42, and I get 13x equals 84, and I'm going to divide by 13, and x equals, gosh, I got to get a calculator for that. Yeah, I got 6.46. We're just going to leave it. 84 over 13 is my answer. That's just got one solution. So the instruction up here says find the value of the equation that makes it true. So we found the value. But sometimes the question says how many solutions does it have? And then we would tell what it is, okay? How many solutions are there to this equation then? Well, let's just distribute. That's going to be 28x plus 28. And then that's negative 7 times negative 4 is a positive 28x plus 20. I feel like we did this problem before. Oh, this is the same question as the other one. We already know the answer to that. All right, you try this one over here. This one looks different. Yes. Negative 6x plus 3. Negative 6x plus 4. I see my negative 6x's are the same, so they're going to cancel when I add 6x. But 3 and 4, they are not equal. There's no solution to this. Okay? Absolute value. This may be a new function to you guys, I don't know, but I'm going to treat it like it is. So absolute value of a number is just its distance from 0 on a number line. So you write it with these two just straight up and down bars on either side of a variable like x or a number, okay? So this is read absolute value of x. So you could ask for the absolute value of 5 like this, just put the bar on either side of 5, and the absolute value of 5 is 5 because if you look up here on the number line, this is how far away from 0 5 is. If you count, you don't count in negatives, you count in positives. You just say 1, 2, 3, 4, 5. It's 5 units away. Distance is always positive. Okay, this is a distance. So my answer needs to be a positive as far as when I take the absolute value of something, it needs to be a positive number that it's set equal to or that we get out of it. So look at the next sentence here. It says, what is the absolute value of negative 3? Well, negative 3 is 3 units away from 0, so the absolute value of negative 3 is 3, okay? And because the absolute value is a distance, it will always have a positive value or always needs to be set equal to a positive value, okay? Let's look a little further at this. An absolute value equation looks like this. Absolute value of x equals 7. So the question is asking us, what numbers are 7 units away from 0? Well, hopefully, if you look at a number line, you realize that here's 0 and this is positive 7. If you count this direction, you're going to count 7 steps. I don't know what that was right there, but that's a distance of 7. And then if you have a negative 7 and you count this distance, it's also 7. So we would say the absolute value of 7 is 7, and the absolute value of negative 7 is also 7. Okay? So we have two solutions. You don't always have two solutions, though. What if it said, what's the absolute value if x equals the absolute value of 0? Well, then there's only one solution. 0 is the only thing that's 0 units away from 0, right? Its distance from itself is 0. But look at this equation. This is saying what numbers have an absolute value of negative 4? Well, there are no such numbers. No number is negative 4 units from 0 because absolute value is a distance. We don't say distances are negative. Okay? The solution has no solution then because absolute value can never equal a negative number. Just remember, absolute value is a distance, and distance is always positive. Now, I don't want you to be confused, because you can get answers that are negative, but you can't have an absolute value set equal to a negative. Okay? And that'll become clear as we do some of the problems here. Okay? So to solve an absolute value equation, you want to isolate the absolute value expression on one side of the equation using the inverse operations, just like if it's -1, you add 1. If it's multiplied, you divide, so on and so forth. Then you're going to set what's inside the absolute value equations to the positive and negative value found on the opposite side. So look over here at the example. First thing I did was I added 1 to both sides, and I got 45. Then I'm going to divide each side by 5 like this, and I'm going to get absolute value of 2x minus 7 equals 9. 45 divided by 5 is 9. And then I'm going to break this up because there are two numbers on the number line that are 9 units away from 0. So that's what this is asking. It's saying what numbers on the number line are 9 units away. So that means 2x minus 7, that has to equal either a positive 9 or 2x minus 7 equals a negative 9, because both of those have an absolute value of 9. And then you'd solve each of those mini equations. In this case, I added 7 to both sides here, and that gave me 16. Then I divided by 2, and then I got 8. I did the same thing over here. I'm going to add 7 to both sides, and I get -2. I'm going to divide by 2, and I get -1. And so these are the answers, because when you plug those back into the original, you end up with 44 over here on the left side. It doesn't matter which one of these two you plug in. You're going to get 44 when you plug it back in for x. Okay, they make the equation true. All right. So here's some examples. First thing is to isolate the absolute value. There can't be anything on the outside of the absolute values that is on this side of the equation. And that step is done for us. So we have absolute value of 5 minus b equals 12. Well, there are two numbers that have a distance of 12 from 0. They are 12 and -12. So 5 minus b has to equal 12, or 5 minus b has to equal -12. So I'm going to split this up into 2 to get my two answers. So I'm going to subtract 5 from this side, and that gives me 7. And I'm going to divide by -1, because that's what this number is in front of the b. It's a negative, but there's a -1 there, so that gives me b equals -7. Okay? And then the second one, you're going to subtract 5. That's canceling out. You get a -b. You get -12 and -5 make -17, and then you divide by -1. And b is 17. Now look with me. I know this is a negative number, but plug it back in. You're going to get 5 minus -7, which is 5 plus 7, or 12, and the absolute value of 12 is 12. Or plug in 17. You're going to get 5 minus 17, which is -12. And what's the absolute value of -12? It's also 12. So these are my two answers. You try the next one. Okay. Hopefully you recognize that you do not need to isolate the absolute value. It's already done. So 9 plus 3c must equal either 15, or 9 plus 3c has to equal -15. So I'm solving those two by subtracting 9 and dividing by 3, and I get 2. And then I'm going to subtract 9 again on this one, and I get -24 divided by 3 makes a -8. Example 6, I'll show you. It has a -8 that's not inside absolute values. I need to get rid of that thing. So let's add 8 to both sides. And I get -3. And I pause right here. And I say no solution. Because you have absolute values set equal to a negative. You can't have a negative absolute value. Okay? Try the next one. Okay, hopefully you realize you've got to divide by -6 to get rid of that -6 that is not inside the absolute value signs. That gives me a -3 equals the absolute value of 3u. And I'm going to stop. And I'm going to say that can't be true. You can't have absolute value equal to a negative. Okay. Here's one right out of IXL. Oh, I think it's the same one we just did. Yeah. This is what they're going to look like. They're going to ask you how many solutions does the equation have. You're going to solve that inequality. And then in this case, there was no solution, so that's what you would choose. Okay? All right, so you're going to find finding the number of solutions to linear equations. That's no solution, one solution, or infinitely many. And then you're going to do some solving of absolute value equations. And those two things, SMART score 60 on C15 and a SMART score of 70 on H1.